Good day to Encik Maslan and my fellow friends. My name is Chong.
My name is Leong.
My name is Ilya Amira Akila.
My name is Muhammad Nasyukri.
In this video, we're going to present and discuss about Lab 5, which is Supervisory Control and Data Acquisition, which is Scada System 2. Let's begin with Task 1.
Okay, so task 1 is PLC Scada programming for four-way traffic light control system. So based on the requirement that is using a CX programmer and also CX supervisor. So
Okay.
so there are no any operating sequence, so we just assume as a normal traffic light. Okay. Okay, so by referring to this supervisor, okay, so we set it to be more flexible for the time for the green light for north, east, south, and west. So it can be independently. So which means that for the north you want to be a longer duration, east you want to be a shorter duration. It can be controlled. And also for the yellow light, you can set that maybe you want to be a longer duration for the changing to red light. So for example, now we change it to east to around 3 seconds. So let's start. Okay, so only 1 second, then we change to so for this, because we are switched to 3 seconds, so we'll be run for 3 seconds.
Run 3 seconds.
And you can see that when the traffic light is changed to red, we have a small delay to change to green for the following traffic light, which means that the green is not on directly after the previous traffic light turns to red. So this means it's become more reality. So which means that there will be no crash. Which means you can see that the car is still going, it's still passing. So which means there's a short delay at there. Okay.
Okay.
Oh, cool.
Okay.
So it seems so for yellow, can set to for example 2. So yeah, this is the indicator. Yeah, the traffic light stop. Sorry. So you can see the yellow will be around 2 seconds. Okay.
Okay.
So this is called animation also because we are using animation editor. Okay, so by referring to this, actually for the track ladder diagram, it's almost similar for each route. And then we use D1 D0. Yeah, this is a data memory so that we can set the D value. Yeah, configure it through this supervisor. If we set for Samsung like #15, this one we cannot be adjusted through CX supervisor. So we need to use a data memory. Okay.
Okay.
So the basic is the same. Yeah. Okay. So for the animation, how we do it? Okay. So let me stop this first. Okay. So referring to this supervisor. Okay. You can see that inside this program project script we have 4 car for each junction. So so those car I'm hide inside here. Inside this. So the purpose that I hide inside here because that I don't want to use visibility. So I will less memory. If you want to be using the visibility also can, but then you need to be consume more memory. So then I don't want. Because I want to reduce the memory as this one because this CX supervisor it's only used for one single call. Yeah, so which means that I want to reduce it. Okay.
They are limited call.
There we have limited, so I reduce it. Okay, so based on these cars, those cars actually are moved automatically, which means that it will detect whether the traffic light is on or off. Okay.
Okay.
So okay, so you can see that so when it reached to the junction, because the junction is around 230, so it will detect whether is it green. If it's green, then only it can be moved. Okay. Okay, so for this one, okay, I take one car. Okay, so the car, this is West Car 4. So we refer to West Car 4. This is the West Car 4. Okay, and this for those script editor, we are using a on regular interval with 50 milliseconds. So you can see the movement is more smooth. Okay. So how to do this? Well, in this point editor, okay, we create different memory.
All right.
So for Rescar 4, we're using Rescar 4 and we use integer. And yeah, for the timer that we're using the data memory, okay, so we are using is green, is red, yeah, this one. No, timer. Timer, yeah, this one. So you can see that we are configured as integer 0 to 100, 10 to 100. Okay, so setup, which is using a D2 and it's called as a single word unsigned BCD. Okay.
Okay.
So you need to configure it to this one. Because normally by using the single word unsigned binary for those basic output and input. Okay, so as usual for the traffic light start running is stop stops run stop. This one will be using visibility, yeah.
Yes.
So
yes, yes.
so which mean okay, when the system is run, then okay, be on and off, vice versa, invisible or visible while true. Okay, so for the timer selection, okay, so I refer to back timer setting. In this timer setting, okay, I also create a point editor. So which means that okay, when I click this timer selector, it will either select 1 to 5. So which means okay, when I press 1, okay, it will be increase 1. So it will be number 2, number 3, number 4, number 5. And I press again, so we'll be back to number 1. Okay. So this is the statement. So for the increase and decrease, yeah, so it will depends on the selection. If it's a select the number 2, so it will be changing for the east. Okay.
Whoa.
Okay.
Okay, so that's all for this task 1. It's okay. I think it's quite smooth, right? Smooth ready for those routines. So you can see when it stop. Okay, the car will stop at the before the line.
Can I set off 5 seconds?
Sure, you can set. So that I increase it with 0.5 seconds. So with maximum of 10 seconds. Because this is just for example. So I don't want to be too high. So we delay. Okay.
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 So let's start. Okay, so going to 5 seconds, we see that's 5 second movement. Oh, sorry. Never mind. This is a colon. So each junction will be running for 5 seconds. And yes, for the yellow, we'll be running for 2 seconds. Yeah. Okay. So that's all for this task 1. Okay.
Perfect.
Okay.
Okay, so now change to task 2. Okay, so for the task 2, we are doing for PLC SCADA programming for an Apple packaging system. So at this task 2, that's given a system operation sequence. So which means, okay, so first we have a sledging system which you normally
stop.
we use. Okay, so start stop, and also a box conveyor and also Apple conveyor. So, but then it doesn't mention that how many apple need to be dropped into the box. So which means we still need to create a flexible variation for user to choose whether they want to be 1 or to 10. Okay, so but this is our supervisor that we designed. We have a box conveyor through here, and a sensor box, and also we have a Apple conveyor and a sensor Apple. Okay, so for the system controller panel, we have start button, stop button, reset button, and also Apple required. So which means okay, user can set it. Either they want to be how many Apple drop inside the box,
Okay, one box.
and also yeah, this is Apple drop, so it will be reset. So for example, we are selected 5 Apple required. So let's start. Same goes same as task 1. We are using
Animate.
blocks, okay, to hide it. Okay, so it will be same because I'm not using the visibility. Okay, so you can see that when it detects the thing, okay, the green light will change to red. So you can see the Apple drop will be changed to red. So same goes to sensor box. When it detects the box, okay, so it will change to red.
Okay.
Mhm. So it will be runs automatically for this one. Mhm.
So each box
Okay,
got 5 apple.
yeah, each box will be have 5 apple. Okay, so for example, we reduce back to, sorry, we reduce back to 1 also can. So every time we start the system is required to press
Reset.
reset button. Yeah. Okay, so when it detects the box, okay, we change to red color, and then this supervisor will be sent to the signal back to the programmer. So one apple. Okay.
So each box will have 1 apple.
So maybe this okay, this okay. So let's stop the system first, yeah. Okay, so for this task too, actually you can see that the ladder diagram is quite simple. So there's a base just a basic command that we use as usual. Okay, counter or the differential down and those. Okay, so same to task 1, we are using the data memory, so we can change the counting number. Okay, so how the system is function at this supervisor, it's similar to task 1 also. We are using the project script. Okay,
Okay.
so for the so for this conveyor, it's not animation, it's not a
Running
complete animation. We are using
distance.
this distance. You can see this one can be moved. Okay, so which means I set to the distance will be the same. So
Continuous running is a certain distance.
yeah, therefore you can see that okay, it will be a linkage. So you can see it's running a smooth. So for the inside here, okay, we have a box here. So how we can simulate the box is the apple drop into the box, but then because that this is we have a raise to top or lower to bottom. So we create two objects. One is box, one is a cover.
Mhm.
So which means that the apple is dropped lower than this cover, but then it's upper than the box. So you can see that it's dropped like a box for a while. Yeah? Hello? Hello? Sorry, Sean, later you cut back.
No problem.
Okay. One project. Okay, so for this one, okay, so we refer back to this project script. So we have doing for this increment, as same goes to the task 1. So we have using it's actually is similar to C++ program, but then we change,
Integer.
yeah.
Okay.
Yeah, so it will be if else, and also but then it will put a then and if. Okay, so at this Apple required number counting number, we are using a not run state, which means that when the system is running, user cannot be changed to Apple required. They need to stop the system. Okay,
Okay.
so therefore
Okay.
therefore I put a condition there. The system is not running, then only can be changed. So when if counter less than 10, so which means that I set it the maximum Apple required is only can be 10, either 1 or either 10. So this one is for increment, and this one is for decrement. So which means counter will set to more than 1. Okay, so for the box detect, this is for the box detect. So because we are simulate only a 3 box is moving through this conveyor, so we'll be back to 0 and run again. Okay, so which means we have only a 3 box inside this simulation, this animation. So when there's a box is in between 490 to 600, which means is at the middle point there. So then it will be send the sensor box equal to 1 to this programmer. Okay, so this sensor box, you can refer back to point editor. So which means sensor box we are using 10.4. So you can see here is 10.4 is sensor 2. By referring to the lab sheet, so it will be S2. Okay,
All right.
so for the Apple is the same too. We are using the Apple detect is the same, and then in this Apple conveyor we are using 4 to 5 Apple. So we have Apple 1 to Apple 5. Okay, so for the Apple, you can see that there's not only moving horizontal, and also it requires moving vertical, right?
Yes.
Similar to
Okay.
this block. Okay, so never mind, I choose 1. So we can set here that 0 to 120. We'll be moving from 0 to negative 120. But then for this one, 0 to 120, it's same, but then we reduce it back to 0 to 445. This maybe we can try and error, so we can meet the desired moving range of our this animation. Okay, so which means that we are only required to set one, which means we are using a one memory, the point, 1 point, so we can simulate horizontal and vertical by changing this one, which means the value and the offset. So this one is similar like y is equal to mx plus c. So it will be convert back to the functions. Okay.
Okay.
So for the Apple, so for the Apple, for the Apple, we are using we are draw inside this CX supervisor because we want to have like a PNG pattern, which means that there's no background. So we are draw. Okay, so we can see that this is we draw inside here, and then we group it. Okay.
All right.
So
Okay.
you can see that it's like an apple because we're using polygon and ellipse to draw. Okay, so we come to apple. Okay, so for the sensor apple, you can see that inside here we have attached a small rectangle.
Colors.
Yeah, this rectangle. So you
Then
can see
color
that color
change.
change. So when the sensor apple is detected, so it will be red. When it's no detected, it will be green. So same goes to this sensor box also. So sensor box, there's also a small box color change. Okay, so that's why we can simulate that when text will change to red color. Okay, so any question for this CX supervisor?
Nope, that's all. That's all for this
No.
test.
Is it clear? I think it's quite clear, right? For this,
Yes.
actually, it's quite a simple things, but then just we have to take time for programming because
Animate.
yeah, this animation will take time.
Okay.
Yeah. Okay, so that's all for our lab 5 from S1/1 group 2.
Thank
So
you.
thank you, sir.
Thank you.
Thank you, sir.